Electronegativity periodic trend presented by Arda, Casey, and Jillian. The definition of electronegativity is the measure of an atom's ability to attract the shared electrons of a covalent bond to itself. As a result, the higher electronegativity an atom possesses, the greater it is at attracting shared electrons. Electronegativity also helps determine an atom's polarity. Analogy. Think of electronegativity as a tug of war. When the atoms that bond together have the same electronegativity, the electrons will be shared equally. However, when there is a greater difference in electronegativity, the electrons will be shared more unevenly. The more electronegative the atom, it will attract the electron pair. Periodic table trend. The periodic table trend of electronegativity is simple. Electronegativity generally increases as you move from left to right across the period and decreases as you move down groups. As a result, the most electronegative elements can be found on the top right of the periodic table, while the least electronegative elements are found on the bottom left. The only exception to this trend of electronegativity is that the trend does not include the noble gases. That means fluorine will have the highest electronegativity, not helium or neon. The definition of electronegativity contains the phrase, in the covalent bond, and since the noble gases do not bond, they do not have electronegativities. A few noble gases such as xenon or krypton have been forced to bond at high temperatures and high pressures, so they may be included in tables. However, these are not terribly important values to know. Explanation. This relates to how we already know about atoms through our knowledge of energy levels. Think of sodium chloride as if it was a covalently bonded element. Sodium is at the beginning of period 3, whereas chlorine is at the end, excluding the noble gas. Both elements have their bonding electrons in the third energy level. The electron pair is screened from the nuclei by 1s, 2s, and 2p orbitals. However, the chlorine nucleus has 6 more protons in it. Naturally, the electron pair gets dragged so far towards chlorine that ions are formed. Electronegativity increases across a period because the number of charges on the nucleus increases. This causes stronger attraction for the bonding electron pair.